All right, in today's lecture we're going to look at a sort of an extended example of designing a data type. So we're going to build a fraction class, and along the way we're going to look at a few things we haven't talked about. We'll look at a few details about how constructors work in Java, how methods can operate on objects of the same type, and we'll look at private helper methods. So normal instance methods of a class are declared public, but you can also make methods that are declared private. And all this will be surrounding the development of a fraction class, all right? And it's developed, it represents fractions like 1/4 or 3/4 and things like that. And towards the end, you get a chance to implement some of the methods I'm not going to show you in the lecture today. Just as a reminder, where do we get our objects from in Java? Well, any kind of sort of non-primitive object we've got to create. We have to use that new operator and instantiate the object. And how do objects like our little colored ball object here, how do they come into being? Well, the object store, the constructor, is what creates the object to begin with. And here's an example constructor at the bottom. We have a ball constructor. It takes three parameters, the x, the y, and the radius, and often what the code inside of a constructor will do is assign the instance variables of the ball class in this example to the parameters that were passed into the constructor method. Now, if you do not have to declare a constructor. All right, so a constructor method is a method that's in your class, but it's named the same as the class, and it has no return type. That's what makes it a constructor. You don't have to declare one. And here's an example of a fraction class where we have not declared a constructor. And the rule in Java is if you do not declare a constructor, one will be assigned to you, or one will automatically be created for you. This is called a default no-arg constructor. There's no code associated with it, and all it's going to end up doing is you're going to create an object, and that object is going to have whatever the default value. So in this case, we've got the numerator and the denominator instance variables. They're just going to either be assigned the value I give. So I could say private int num equals 5 if I wanted to, but if you don't specify something there, then it's going to take the default value for that data type. In the case of an integer, that's going to be 0. So first rule, if you don't declare a constructor, you'll get one automatically. It just won't do anything. If you've got a no-arg constructor, when you instantiate your object, so in this example we're instantiating a fraction called a, equals new, so the new operator is signifying we're calling the constructor. Here's the name, the name of the class, and then you must give a parameter list. Even if you want to call that default no-arg constructor, Java requires you put the empty parentheses there and basically say, I'm calling a constructor. It's just the constructor doesn't take any parameters. And in fact, in the example I just showed you in the prior slide, there is no actual method you could point at in the fraction class. But nonetheless, to create that fraction object with the no-arg constructor, you need to use those empty parentheses. Importantly, remember, whenever you create an object, an array of reference types, we're saying, please Java, I want a frax variable, and that data type is an array of type fraction, and please make me 2 entries. So I'm calling a new operator, but here the difference is I'm using the square bracket. So this is saying make me an array that has the potential to hold 2 fraction objects. Now it doesn't actually contain any fraction objects until I go through and instantiate an object into each element of that frax array. All right, so a typical style is you first create the memory for the array, and then you go through either explicitly or in a for loop or something. You go through all those, you iterate through them, and create the objects in each of the slots in the array. Normally, you're going to, in most classes, except for really simple classes, you're going to declare your own constructor. All right, but you need to understand once you do that, Java will kind of pull the rug out and take away that default no-arg constructor. All right. As soon as I declare a constructor, so it's a public method, it has the same name as a class, it has no return type. All right. In this case, it takes the numerator and the denominator of the fraction and then assigns the instance variables equal to it. That's fine. And now whenever I create a fraction object, I must pass it two integers, a numerator and denominator. That default no-arg constructor has essentially been destroyed, or I don't know, it's not there anymore. Okay, and if you had code that depended on the no-arg constructor, you've now broken it. And here's a client, and it was calling this no-arg constructor up here, as well as the no-arg constructor here in the array, and none of this will compile anymore with the fraction class I just showed you, because the only constructor form, as soon as you declare one, the only constructor you have are the ones you've explicitly declared in the class. And you'll get an error like this, constructor not found. This does not match the only constructor, all right, it could find. Takes two parameters, an int and an int. Not too hard to fix. If you really in fact want a default no-arg, and maybe you do, you want to whenever you create a fraction, if you don't specify, you could have a fraction that just has a 0 in the numerator and a 0 in the denominator. You have to actually now explicitly declare it, and that's what I've done here. I've declared a constructor that just doesn't do anything. And this is an overload situation. I've got two methods with the same name, just different parameter lists, and that's got to be the case, right? They have to differ in the number or in the types of the parameters those overloaded constructors take. All right. Another thing we haven't maybe seen, or maybe you haven't seen, is passing in parameters of the same type as yourself. And here's a special circumstance, one called a copy constructor. Often, sometimes what you want to do is you've got an object of a certain type, and you want to create a new object that's an identical copy. And a copy constructor does just that. In this constructor, I'm passing in a reference to another fraction object. And what do? Well, I copy the data. I say my numerator is equal to that guy's numerator. My denominator is equal to that guy's denominator. And now I'm a copy. I'm the same fraction, but I'm a different object. And so somebody could come along and do something, change me, make me the reciprocal, or do something to my, the one fraction object without impacting the other one. Right? That's one thing I wanted to show you on this slide, is the idea of a copy constructor. So it's a common thing you'll see in a lot of software. The other thing I wanted to show you is how it's getting there. It turns out you can get to private instance variables of parameters that are of the same type. Because I'm a fraction, I'm an instance method, and I'm a constructor in this case, but I could be any other instance method in that fraction class. Because I'm inside the fraction class, oh, excuse me. Because I'm inside that fraction class, any instance method of the fraction class, if you pass it another fraction object, it's allowed to access the private instance variables. So I can just use the dot and then the name of the instance variable and get to that instance variable. And you might think you can't do that because of data encapsulation, but you kind of trust. I guess the idea is at least in Java, you trust objects of your own type. So if you're an instance method of type fraction, you're allowed to look at sort of the private, the private data of other fraction objects. Often by convention, I will call the parameter like this other, and there's nothing special about the name other. It's a variable name like any. I could change this parameter here, and I could call it O, or I could call it foo or whatever. It's just the parameter name into the method. But often it helps if you call it other. Then you kind of think of I'm my object and the other guy is the other object. So it helps you keep it a little straight. All right, let's do some fractional, some grade school fraction computations. And the first I'm going to do the easy ones, and you're going to get through the hard ones. Multiplying fractions. Given two fraction objects, return a new fraction that is the multiplication of the two. All right. We need two fraction objects. So do we need a method that takes as a parameter two fractions? Not if we're going to use instance methods. All right. we're creating a new fraction by taking a and multiplying it by b. So there are two fractions involved. There's the fraction that's running the instance variable or the instance method multiply, and then there's the fraction parameter b that's getting passed into that method. And then they're going to return a new fraction object. And I'll show you the code. And here's the goal, right? We want to have 1/2 times 2/3, so 1/2 of 2/3 is 1/3. That's our goal. Let's take our first stab at implementing this multiply. And if the multiply method is returning a fraction object, you're going to need to new a fraction object inside of that method. And that's what's going on here. We're creating a new local variable called result. It's of type fraction. I'm instantiating it by calling the new operator. And what shall I create the new fraction to be? Well, what's the multiplication of two fractions? It's my numerator times the other guy's numerator over the other guy's denominator times my denominator times the other guy's denominator. All right, this is what this fraction c equals a dot multiply b is. Numerator would be the numerator of a. Denominator would be the denominator of a. Other dot num would be b's numerator, and other dot denominator would be b's numerator. That would get put into the result object, and then that's what's actually, the variable c is going to refer to as that result object. Does it work? Not so much. Here's the code. I'm doing the multiply, and what am I getting? Well, whenever you see something like this, all right, what we're doing is we're printing an object of type fraction, then we're printing out, double quote star, double quote, and then the fraction b, then an equal sign, and the fraction c. If we don't do anything, these are of reference type, and Java will go ahead and print these, but its default format is just to print the class name, @ and then memory address. All right, not terribly useful. At least you can tell it's kind of working, but it's kind of not what we hope for as far as output from our fractions. How do we fix that? Well, in Java, there's a toString method, and what you can do is the fraction class is allowed to override that fraction class or that toString method. So if you declare a toString method in your fraction class, whenever you call system.out.println with a fraction data type, it's going to call toString. And toString, for this to work, it needs to be public, it needs to return a string, and it needs to be named toString, exactly like this, and take no parameters. This will be a very common thing we'll be doing in a lot of the classes we'll develop, because often we want to print them out, or in order to debug them, it's handy to be able to just send the object into a print statement and get some sensible representation. And in this case, okay, I'm putting the numerator and then putting a little slash and then a denominator, and then I return this string, and that becomes the output from system.out.println. So system.out.println automatically will call this. So you don't have to call .toString. You just get that automatically. These lines here would now call. It's kind of like doing a.toString, and you could do that, but there's no particular reason to do that. It will automatically happen for you. Now, I forgot to mention, so what's the problem? Well, let's say we want to actually display this in lowest terms. 1/2 times 2/3 is 2/6, which is true. But normally we'd reduce 2/6 to lowest terms and have it output 1/3. Here is some code that does that. And first of all, I've got the beginning of my multiply. I do the same thing as I did before. I take the numerator and of the 2 and multiply, and the denominator is a 2, and I get my new fraction object. But what I'm going to do is try and find the biggest number that divides evenly into both the numerator and the denominator. And if that has any chance of succeeding, right, there's no sense in starting at the biggest number. We'll start at whichever the numerator, after doing this multiplication, like in the last slide, right, I do that multiplication, the numerator would be 2 and the denominator would be 6. And what I will do is start my I at the minimum of those two, and if that is 0, so this would happen if both the numerator and denominator is 0, I'll just give up, all right, because I don't want my program to crash All right, it's usually bad in most programming languages. If you try to divide by 0 or use something like the percent the remainder operator, if you've got a 0 in there, it's going to crash. So if it's 0, I just don't do anything. Leave it at 0, 0. That's fine. If it's not, then what I do is I start at that I, which is the minimum, the minimum of the two numerator and denominator, and I see, well, this first is shorthand for does that number I evenly divide in the numerator, okay, or does not, sorry. We want to keep going as long as what we're looking for is the number I to evenly divide into both the numerator and the denominator, and then we stop. So as long as it doesn't evenly divide into the numerator or it doesn't evenly divide into the denominator, then keep reducing it. So we're going to start at something like 2 and say, well, does 2 divide into 2? Yeah, it does. Does 2 divide into 6? Yeah, it does. Then we're going to exit out and not reduce I anymore and divide 2 by 2 and 6 by 2, getting 1/3. All right. That's a simple example. So in a more complicated example, I might start at a higher number and then work its way down until it finds that biggest common denominator, and then it's going to divide both the numerator and denominator. And this is okay. So normally we'd be kind of worried here, right? We've got the slash, and the right side's an integer and the left side's an integer, and so that's integer division, but it's okay in this circumstance because we know it's evenly divisible. So integer division and normal floating point division would be the same thing, and actually we want this to type to integer when we're done. Great. That's the code for multiply, and we're going to reduce it to lowest terms. And I should say, like, when I do this fraction class, there are a lot of sort of design choices I've made, and these are just some of the ways you could imagine building a fraction class to work. It wouldn't necessarily be the case that I would always want to reduce, multiplication to lowest terms. I'm just showing you some of this for sake of an example, and it's up to you when you design your own data types exactly what things do. Let's do division. Okay, and to do division, all right, we're going to take the numerator, the other guy, and times it. So I'm a fraction, right? I have a numerator and a denominator, and essentially what I'm doing here is multiplying by the reciprocal of the other guy. So I flipped his denominator and his numerator, and it's the same as multiply, except for that. And I have the same issue with divide, is I need to reduce it to lowest terms. And so if you look at these two slides, all right, all I've done is done that swap in the top, okay, and this code to reduce it to lowest terms is identical. All right, and if you remember our saying, repeated code is evil, we really don't want to have this somewhat complicated algorithm to reduce to lowest terms in two places in our code. And so I'm going to show you how to do that, because you're going to have a similar issue in add and subtract, and a lot of other methods are going to need to reduce a fraction to lowest terms. And so rather than repeat that code, what we're going to do is put it into a helper method. Here's the helper method. I'm calling it a helper method, and I'll often say that when it's a private method. All right, it's declared private, which means no one outside of the fraction class can ever call reduce. And that's, again, a design choice. Maybe you could make other choices when you build your fraction class, but I decided I will take care of reducing the lowest terms inside of the other methods like multiply. And what I've done is just move that code into here, and I'm a fraction, and all I'm going to do is look at my numerator and my denominator, and I'm going to work my way backwards and find number that evenly divides in both. Okay, and I think I've almost taken that. Yeah. Yep. So that's what I've done. And now I can change my multiply, call the dot reduce on the result, and then return the result. So this will always return a multiplication that's in lowest terms. And the advantage, obviously, is now I didn't show you the divide method, but the divide method can do the identical thing. So I've showed you the main things I wanted to show you today about no-arg default constructors and other overloaded constructors, and we talked about private helper methods. And now what I think you should do is complete the missing code from the web page, I'll put a link to a fraction class. It's similar to this. It has more comments, and I think I put in some temporary code in all these methods just so it compiles, and you can work on. And it has a big test main that you can test out once you've implemented the equals method, the reciprocal method, the add method, and the subtract method. And